The graph shows the result of the titration of a 25 milliliter sample of a 0.10 molarity solution of a weak acid, HA, with a strong base, 0.10 molarity of NaOH. Two features of the graph that help identify HA as a weak acid is that we can note that an initial pH of the solution is at 3. The expected pH for a 0.10 molarity of a strong acid is 1. Also, for the titrated solution, the equivalence point is above 7. With a strong acid, the equivalence point should be at 7. One method by which the value of the acid dissociation constant for HA can be determined using the graph is to find the pH at half equivalence point in the titration where Ka equals 10 to the negative pH. To further explain, we know at the half equivalence point pKa is equivalent to the pH. We also know that pKa is equal to negative log of Ka, so we can substitute pKa in that equation with pH to get negative log of Ka equals to pH. To cancel out the negative, we multiply both sides by -1 to get log of Ka is equal to negative pH. And then to cancel out the log, we have the 10 raised by the negative pH, and that is how we find our acid dissociation constant for HA. On the graph is a sketch of the titration curve that would result if 25 milliliters of the 0.10 molarity HCl was added instead of 0.10 molarity of a weak acid. The initial pH is 1. At 25 milliliters, equal amounts of the acid and base are mixed. The equivalence point has a pH of 7, which means that it is neutralized. In Part D, a 25 milliliter sample of 0.10 molarity HA is titrated with 0.2 molarity NaOH. Part I asks us what volume of base must be added to reach the equivalence point. So we can find the amount of millimoles by taking 25 milliliters of the sample and multiplying it by the 0.1 molarity of HA, and since we have equal amounts, we know that we have 2.5 millimoles of OH minus ions, and to find the volume we can take the 2.5 millimoles of OH minus and divide that by the molarity of 0.2, and so we get a volume of 13 milliliters needed of base to be added to reach the equivalence point. In the first titration, where 0.1 molarity HA is titrated with 0.1 molarity NaOH, the total volume is 50 milliliters. In the second titration, 0.1 molarity of HA is titrated with 0.2 molarity of NaOH and has a total volume of 37.5. The smaller volume in the titration with 0.2 molarity NaOH means that the concentration of A-, which is the molar concentration of the conjugate base of HA, is larger compared to the molarity of the A- at the equivalence point with 0.1 molarity NaOH. Therefore, the pH is slightly higher.